You're listening to All Things 3D, where we talk about the world of fabricating, designing, and capturing in the third dimension.
Hey everybody! All Things 3D.
About 6 months ago, we decided to make the M3D Pro based on getting feedback from our existing users. So we've already gone through 3 iterations of design prototypes, and we're almost completely done the engineering. 3 months ago, we proved a lot of the important concepts like making a heated bed that uses less power, proving that it can move a lot faster, proving the benefits of higher quality and higher precision metal parts. And right now we're going through the final phases of proving the feedback system and finishing the next steps in programming.
First time I ever heard about 3D printing was one of my friends printed a Ninja Warrior training hold, and I thought it was really cool.
The unique thing that you're getting with M3D Pro that we have not yet seen in this industry is that ability for the printer to sense many different things within itself. It has the ability to sense position, it has the ability to sense speed, it has the ability to sense temperature in 5 different places, and if there's a problem, it can be self-diagnosed, and in almost all cases can be self-corrected. Ultimately, that gives you more time in the creative process.
With 3D printing, I have right on my desk, or my granddaughters have right on their desk. If they get an idea, they can try to make that idea on a 3D printer right there. They can turn their ideas into reality. This I didn't have when I was a kid.
Really, the greatest advancement that 3D printing could accomplish at any point in the future is ease of use, making it so that anybody can just go from an idea to creating that idea within an afternoon.
We've introduced this new thing that we call tutorial mode. So what we got from our feedback from original backers was that they wanted more detailed guides so they can grow into becoming an expert user rather than having to start as an expert user.
The thing I think that needs to happen for educators is speed is an issue, how fast we can turn around.
So with M3D Pro, you have the ability to print a single prototype with extreme accuracy and high quality, but you also have the ability to take that prototype and print it in quantity, cover the entire print bed with multiples of your model and produce it at volume.
I am so excited for the future, not only for me, but for my daughter, to grow up being able to use her mind to create anything she wants to, thanks to a 3D printer.
I've been fascinated with just the whole idea of 3D printing for quite a while now, focusing on just simple things that I could print for around the house, or toys that I could print to play with my kids. Really just the idea that I could create something myself.
What's unique about the Kickstarter community is they value innovation. And what M3D is doing, I think many people are going to see as extremely innovative, and they're going to want to be first to support it and to help nurture where this technology is going to go. They just also happen to get a printer as one of their rewards very early and at a deep discount.
Awesome. Well, welcome everybody. It is August 26, 2016. It's All Things 3D. Hey, Mike.
Hey there. No, actually, 2 of us can say hi. So
yeah.
We actually have a new person with us, and that is the CEO, Mike Armani of M3D, who just released this outstanding, if you look at my screen behind me, the Kickstarter here, that in minutes, you're able to exceed your $100,000 goal, and now you're almost 4 times that, which is fantastic. Obviously, you're probably thrilled with that. But that's not because you have not been unknown to the 3D printing market. You had this nice cute little thing called the M3D Original, which is in the image here. But now this is the Pro. But you had the little tiny one, like you'd fit in your pocket. Yeah, there you go. And let me jump to your screen now.
It's for reference scale here. It's a micro 3D printer because it's so small.
Well, we've covered it in the past. I think we even tried to get you on, but you were big stars then, not that you're not now. But yeah, we've been following it, and we think it's actually kind of cute. And this is our month for 3D in education, and we've had a few different companies on to talk about hardware and not necessarily hardware, design tools. So we wanted this last episode to be kind of our anchor show where we're going to be talking about 3D fabrication and the actual devices. And I thought, why not get Mike on to talk about their product? Because one, it's one of the more reasonable, and if I understand correctly, you're based here in the United States. Is that correct?
Yeah, I think we're one of the last ones left.
And that would be another reason that get somebody within the U.S. I know that we've covered a number of 3D printers from China that are very reasonable and in the same price category, but it's nice to have somebody here in the U.S. as well. Not that I am Go USA or anything. I'm a world type person, but it's nice to know that. And like you said, MakerBot has skipped town. So enough of me talking. Why don't you tell us a little about yourself, your company, and where you're located? Because if that's where you're located there, looks like you're like in Kansas or something, or maybe that was just a 3D object. So go ahead.
Sure,
you got
sure.
The floor.
So, thank you. Mike Armani, CEO of M3D, a co-founder. So yeah, we've been around now for almost 3 years, big in this space. Yes, we are in the U.S. We're on the East Coast, not Kansas, actually just between the capital, D.C., and Baltimore in Maryland. So it's right in the middle. So it's kind of suburban with a 20-minute reach to the inner city, which is pretty cool. You can stay out of traffic, get a lot of space for cheap without having to go really far to go somewhere cool at the same time.
So is it as flat as the video, or
that one section of our town, yes, it was bulldozed 19 years ago and has been like super planned as a what do they call it, like a work-life community where you can have industrial buildings, commercial buildings, and houses all in the same block.
Yeah, kind of reminds me of some of our locations here on the Central Coast. Okay.
So what makes this unique? I want to go into that since you brought up China, and same thing here. We're not always pro USA. It's more about the challenge of we like being here on the East Coast and we don't want to have to leave our families and our friends and go overseas to manage stuff. So it's been a big challenge and something that we're very prideful of, that we seem to be able to provide a globally competitive price point without having to reach outside of the US nearly as much as some of these other companies have. And why is that possible? I think it's one is honestly just sharing the cost cutting. We are giving a lot of discount away perpetually to our buyers, knowing that this is a 10-year goal of getting inroads into the 3D community and leading it, rather than, hey, I want to make a quick buck today because some exec told me go get a piece of that market. So that's really what it's been about for us. And to do that, we've actually put everything in one building. Our facility is 12,000 square feet. And from the very beginning, the design, the engineering, the programming, the actual build out, the sourcing, the shipping, pick and pack, customer support, everything, marketing, admin, it's all under one roof. And while it is more expensive to run a company in the US, it is incredibly efficient to have everybody within 30 feet walk from where you are, or maybe 100-foot walk from where you are. That efficiency is a drastic increase. You can react quickly, you can turn things around in a couple days rather than putting it on a boat and waiting 3 months. So that's largely where we get our more reasonable prices from.
Good. So you did mention that the assembly process takes place here, or do you actually, where do the parts come from? Obviously, some of the parts, like your stepper motors and things like that, are probably purchased from abroad and then assembled, or how much of it is actually manufactured, how much is assembled?
It's a good question. We like to go with the number 50-50. So all of the raw parts, tiny parts, things that are frankly impractical to purchase in the States, things like screws, carbon rods, motors, pretty much intricate, tiny things come from overseas. All of the large parts are actually made in Maryland. Our frame, the polycarbonate injection mold, is about 30 minutes away from us. The packaging, the electronics are made also up the street, and that's also important for maintaining the IP, keeping it secure. So roughly at the end, half the costs are going right back into our own state, and almost 100% of the assembly is being done in our building here. So we get all the small parts from overseas, but then we do all the labor here.
Now, did I understand correctly? Your controller board is manufactured right then and there in your local town, or not local, in your state? That's cool.
Yes, yeah, it's about 20 minutes away actually.
Well, that sounds like somebody who's got their head wrapped around this. Well, let's talk about the little guy behind you. Now, I don't remember the timetable when that came out. The little blue guy behind. A lot of people were enthralled by it because one, if I remember correctly, was not the price $299 or something like that, about $300 if I remember correctly.
Yeah.
That was unheard of, and so there was another company who was kind of a fly-by-night. I can't remember them. They had a little product around Christmas time for like $200, and it was about the worst $200 I ever spent. I mean, it was a disaster. I don't remember the name, nor should I mention it, but some of us who have gone back a couple of years probably remember that little ugly device. But so obviously a lot of us had a trepidation of, another low-cost little tiny printer, what can you do with it? But obviously you've done something with it, and it's become very popular, one, with kids, but families who can't really afford. If you remember, the MakerBot when it first came was like $2,000. So this was a big thing. So can we kind of talk about the history a little bit? I think I'm jumping around with the questions here. Let's talk about the history of M3D as far as the popularity of that. And obviously you must have a fairly decent name for this thing to fly on the Kickstarter right now. So let's talk about the little guy first.
Sure thing. And I'd just like to put in a personal touch on this topic because I think there's a lot of misinformation about what's really going on in the industry, about some of the hype that's there, both now and originally, and what we really did and how we see the micro fitting in. So when we first launched the product, it was Dave and me sitting in a basement saying, we love to use 3D printers, but they're so expensive. And I think everybody who starts a campaign pretty much comes from that angle. They're like, okay, here's some threaded rods. I could go buy this at Home Depot. Here's some laser cut wood, $2,500. Wow, that's insane margins. Let me go build one, with my son and start a Kickstarter or something. I saw a lot of projects coming out like that, and what I thought was missing was a couple of things. I mean, one of them was they didn't make a product that was attractive. A lot of people, I hate to say, they call it the wife test. Is it something that you have to keep that in the garage? It's loud, noisy, smelly, looks dangerous, untrustworthy. Or is it something I can reasonably bring in my office and it just fits? So
let's
that
call
was
it
one thing.
The kitchen test. Will
Kitchen
it
test.
work?
Sure.
Can I put it in my kitchen?
Sure. So there's that test. I largely started on the design side and very severely restricted the engineering team with the demands. So it was always, what, you want to change the curve? No, find another way. So I think that's one of the things that truly resonated. If we're honest, it's a cute printer. It's got a nice industrial design, especially for the time it came out. There really wasn't anything like it. There were cheap printers, there were kits, there were incomplete user experiences, but there was never a $300 printer that basically promised it all. Now, from our perspective, we weren't trying to fix everything in the 3D printing industry and make a flawless user experience all in one go. That's something that takes a decade, to be honest. There's a lot of feedback and a lot of iterations that have to happen. Much like the early Apple products, they were not perfect to begin with. They were kits. They had issues. They had issues at every aspect of their business. So our goal was just to get proof of concept that we can assemble these things affordably, that we can make a tiny printer that works well, and we did not set out to fix every single issue in this industry. So I think a lot of people, because of the hype, can easily miss that point and are maybe not aware that 3D printers still require some pretty heavy learning curves at times. There's a couple models you can definitely set up in 10 minutes, hit print and go. But for more advanced stuff, especially since the model side hasn't been curated well, there's a lot of trial and error, and there's still a little tinkering with the hardware that was out in the last few years. So that's how we see ourselves. We see ourselves coming in at a nice price point with a good look, with a good feel, with a good balance of cost, power, and quality. And that's what I think made the micro hit so hard, when we came out with it at that time.
Yeah. Chris, do you have any questions? Mike, your background noise seemed to have risen there. I don't know if you've noticed that. Let me mute you to see if it actually is you.
So what I want to know is basically what is the main difference between this new Pro model and the other model?
Yeah, well, we'll get to that, Chris. That was one of the questions. But since you've asked it already, let's go ahead and move right into it.
Okay, can you hear me okay?
Yeah.
Well, there's still a lot of background noise, but we'll go ahead and move forward with it.
I can ask Ricky, can you do me a favor and just turn off the AC? I think that's getting in there somehow. Okay, so huge difference. I gotta even think about where to start. So the micro was, let's say, an exercise in how can I make the 3D printer as cost effective as possible, bringing down the unit part cost so decently expensive American labor would still lead to an affordable product. The Pro is basically completely turning that upside down for us internally as an engineering team. What we saw was parts that had to be tinkered with and filed, and they wouldn't always work perfectly. So we have people in here that are subjectively trying to make it work perfectly, and ultimately that results in some variability for the end user. And the same thing for the system itself. The technology wasn't closed loop as all 3D printers are. Actually, I like to think of them as set it but don't forget it, or they operate on faith. You start the print and you hope it works, and because there's that uncertainty, there's so many people putting things like webcams on their printer, which I understand are cool, but you shouldn't have to worry about your 10-hour print failing that you get a text message alert or something like that. So what we started with the Pro was this concept of locking down these open-ended systems using feedback loops. And an example is almost all 3D printers use a thermistor or thermocouple as their temperature sensor. That is pretty much the only closed-loop system there is, which means if you go off temperature, you can detect it very accurately and come back to your baseline or your target. On the other hand, if your motors are moving off the track because it hit a snag or someone bumped the table or whatever, there's a small part of your print that was mechanically in the way and it warped slightly or something like that. All of those issues are going to cause you to waste filament, your print's going to fail, you're going to have to start over. Same thing for power outages. That's one that people like to ask about. It's not a huge issue, but it proves the point. It's very cool. There's lots of temperature issues with things like fans. They run at one speed. They don't necessarily react to different environments. Same thing with heated beds. So what we did was we put over 24 sensors in the Pro. And what that does is it completely closes the loop. It takes the questions out of the system. It allows us to do very detailed remote diagnoses. It allows the system to calibrate not just initially, but also in real time on the order of microseconds. So all of those lead to what we hope inspires a new generation of 3D printers. Those are 3D printers that no longer fail, that no longer require TLC, that basically you hit the print button and they actually work every single time. So the goal here is reliability. That's just on the software and the electrical side. On the hardware side, we also got rid of almost all of the plastic parts. With the micro, everything was injection molded as much as possible. These are parts that have pretty big tolerances. They are a couple paper widths off at times. And we decided to switch completely to using high precision metal. Those are parts that are typically toleranced in the 10 micron range, which is about 15 times more accurate. So you can take two rods, stick them together, they work perfectly the first time, they're always within spec, and that ultimately leads to a much more consistent printing quality, printing experience as well. So huge difference, we think.
Yeah. So let's go through real quick on your Kickstarter, and then I'll come back to you. So first of all, you have a larger build volume, so it's now 7.5 inches tall with a 7x7, so it's a square actual bed size. It is now a heated bed, right? The previous version was not heated, if I remember correctly.
Right.
So it's now heated. Your accuracy is anywhere between 25 to 350 micron layer heights.
In the Z, yes.
In the Z-axis, and 0.4 millimeter nozzle extension, which was fairly common, and then fast printing. So there's something there. Now I noticed the rod system The control system is very similar to the Ultimaker. Not They also use a slimmer rod system, and that I think also contributes to their fast speed. So maybe we can talk about that a little bit. You say you have a standalone mode now, so I assume that you don't need a computer. SD cards, is that correct? Or maybe even Wi-Fi, third-party filaments, and which is very interesting because some of the people who are creating low-cost printers have these custom cartridges and you're locked into their systems, so that's a good feature. Embedded recovery mode and advanced sensors, which you just talked about. Let's kind of go back to the standalone mode. That's something that Chris and I kind of raved about, because when we first started out, you had to have a computer hooked up to it. In fact, I have a system set up specifically for that so that I can go directly from the slicing program to the printer, but I also have backup SD cards. So what can I do from a standalone perspective with this?
Good. So yeah, one of the biggest points of feedback we got from the micro users was they did not like having a tethered system. Now, we did it initially just to reduce the development lead time, and it reduces costs a little bit. What we did this time is, and we specifically don't advertise SD card because we don't want to mislead anyone, but there is an SD card internal to the electronics. We have them buried in there because it's just a design standard that we created. We don't like the idea of, and we don't see it as necessary for the long term to have a USB flash key or an SD card that you walk around with, because that's not something that's become predominant with things like inkjets and laser jets. People just go to a network printer and they hit print, or they connect their computer and they leave it at that. And the other reason we did that is because that can be a very simple add-on that you can put on later. So there's extensions for the SD card where you can bring it out. But the big reason is there is no LCD screen in this model. There is no standalone touch screen where you can browse your SD card and hit print, or have a button to be able to hit pause. That's a huge cost reduction measure for us. But the principle is still there. You plug in your computer, it transfers the data over 30 seconds or so over the USB, and then you're done. You unplug it.
Okay, pretty cool. So did we say there was Wi-Fi or
this
something
model,
like that?
Yeah, this model doesn't have Wi-Fi, and that's just a very expensive development pipeline, but we designed it so that you can put on a USB attachment that will be the Wi-Fi host.
Okay.
So Octoprint compatible? Will Octoprint work?
Yeah, so we completely redid the G-code so that it is absolutely industry standard in every way with the Pro. We tried to do it with the Micro, but it turned out those electronics were a little too limited for it. It still works, it just requires a lot more understanding.
Okay. So I'm assuming also with different slicers as well,
Yes.
Simplified 3D or Cura or something like that.
Yeah, we use both Cura and Slicer now with the Pro.
Okay. And then printing speeds, obviously those are fairly fast. How did you go or come about doing that? Was it, as I indicated, using a lighter weight thin rod versus a heavy screw system? Maybe give a little insight of how you were able to improve the performance.
Yeah, so the even the micros are capable of going not too far from that fast. The thing is, with them, we have to slow them down as a precaution. They have no way of self-calibrating to their own limits, and they have no way of recovery if they fail. So, initially the micro is driven on these pretty light motors already, so it has that advantage with a light gantry so that it can move quickly. The Pro difference is really that it has the ability to sense if anything goes wrong, which is, it might be 1 out of a million moves, but that one error is enough to completely ruin your print. In this case, since we can correct it on the fly, we know we can guarantee 60 millimeters a second just on the printing side. We're actually doing 80 right now. So that's easy at this point. And so the whole premise of cost reduction, and I think something that needs to be said is this: most printers use NEMA 17s. They're rather heavy, very bulky aluminum can motors, and that's a good starting point. It's an expensive motor and it's very powerful, but because other 3D printers don't have the ability to sense where the printer is in real time, they actually have to tune it back a huge amount. So your typical 3D printer, an Ultimaker for example, might be able to move 300 millimeters a second. I don't know for sure, but it's up there. But they'll always end up printing in the 50, 60 range. You'll hear a couple guys talking about how they did 150, but it's one specific print that they've super tuned, over many days. and it's not practical as a one-size-fits-all speed. On the other hand, we have these very light motors that would be inferior without this sensing technology, but because we don't have the worry that it's going to have an error, we can actually push them beyond what those more expensive motors can do. So ultimately, that's more savings that we pass on to the end user.
Okay, so obviously the end result is to ensure you get good prints, and one of the things I requested is, could you show us possibly some of the great prints that you'll be able to get on the Pro and even on the, what do we call it, the M3D?
Micro.
The Mini-Me and the Mini M3 and the, no, just kidding, but...
It's gotten lots of names. It's the Micro 3D printer, but I think 4 out of 5 people ended up just calling it the M3D because that's the only word on the front of the printer. We went a little too minimalist with it.
Well, I think that works. So do you have a print to show us?
We've got a print. We've got a printer on the other side of me that's actually printing. I'm gonna try to bring myself up so I can get this in frame. All right, I think I got it. I hope I don't regret moving this webcam. So we're in our engineer's office right now with a prototype Pro over there. Yeah, try to move in there with you. So what we're doing is, can you still hear me well?
We can hear you great.
So what we're doing is we've got 3 different prototypes, and I don't want anybody to be misled by what this process is. There is no final, finished, perfect production prototype until we're done, until we're shipping, November units. So what we have right now are printers in various stages. So this printer here is actually designed for us to test the first layer starts, and we've actually gone pretty wide with it. It's printing at an okay speed. I think it's around 50. And we have other printers in other configurations. One of them which is just dedicated to the error correction part. And we have another printer that's just dedicated to trying to push the speed limits. And every day we actually take it apart and rebuild it. So one of the next rebuilds that we're going to do is we're going to take apart the printer and put these new lead screws that we got in. These are precision lead screws with less than 20 microns of run out, which means the straightness of the rod. And ultimately that leads to extremely good, in theory, leads to extremely good straightness. I don't know if you can see that, but that's the effects of bad straightness. That's probably a unit that we would reject on the Micro, let alone one that has extreme straightness is going to look, let's say, a bit more like, I'm trying to show you the edging of the layers. So there's a lot of work that has to be done to just finalize it, but it's easy stuff. It's an engineering standard going forwards. So some of the actual first prints that we did on some of those crude prototypes, the one you saw in the video where we're basically printing on a block of wood, that's just the first print. So it only goes uphill from there. We decided to approach the Pro very differently than the Micro. Rather than show completely flawless prints that have been super refined and then disappoint, we're trying to do the opposite. We're trying to say, okay, here's reality, make sure you know what you're getting into with a Kickstarter. We've been through this before, so we don't want people to be disappointed. If you have doubts, wait until it's retail. But if you understand the process, the iterative engineering experience that you're going to go through with us, back us early. So so that's why I try to minimize the prints, because I think that's missing the point of the innovation a little bit. It's a given. It'll be fast, reliable, accurate.
Awesome.
Great. So, I think I've read that it's actually, if you got in there early, you could get it for what, $400, but I think the retail price is going to be about $500 for the Pro. Is that correct?
Hey, Mike, you've got an email writing behind you, by the way. If you want that up.
No, I don't. Thanks.
Yeah. Sorry. So, can you say your question again?
Actually, Chris, can you go ahead and pass that question? I need to take the phone call.
So I guess what he's wondering is what we can expect in the next 4 months or the next year from M3D. Like what's in the pipeline? So you guys, and what's the shipping timeline on this?
Good question. So in the next 2 months, we expect to completely finalize all of the engineering aspects, and this is all detailed in incredible honesty and accuracy on the Kickstarter. So what we've done is we've essentially drawn a graph that says, here's the next 2 months, these are engineering challenges. Here are the next 3 to 4 months, these are electrical and firmware challenges. Here's the next 6 months, these are high-end software and user challenges. And with each one of those things being completed, with engineering being done in 2 months, those are the first beta test units. Those are units where you expect there's going to be significant limitations in features. So for example, tetherless mode might not be ready yet. And there's a couple dozen people that understand that and got those printers. So that's November this year. January, we finish all the electronics, all of the electrical programming, all of the internal firmware. That means that things like tetherless are going to be coming on for the first time. But something like our walled garden of curated models, our end user, support, a widget that comes up and says, how did your print do? What settings would you recommend for others using this model? That sort of thing, that very high-end user experience hasn't been done yet. And then 6 months, we finish everything on the user software side. So that tutorial mode that we showed, things like that. And that's why we call it market ready. So we've really tried to dumb down the expectation of what was considered market ready before was, hey, we successfully built a printer, but the software's not ready. Today, we want market ready to be understood as you're expecting to take it out of the box and it's going to work perfectly because all these other people have vetted it before you. So yeah, basically 4 months for the first production units to come out in mass, and I think you'll be surprised what you see. We have a survey that's going out in a couple days, and what we're going to do is ask the almost 1,000 backers that we have now, what are your hopes and dreams for this printer? What are you trying to build? What is your first model going to be? And what we're going to do is curate about 20 of those applications and start printing all of them in-house. And what I expect to find is some people are going to do miniatures. Some people are going to do really large boxes. Some people are going to do trinkets that need moving parts. Some people are going to want circles and gears that are perfect. And what we'll do is we'll set up a alpha test station in-house for each one of those. And obviously we aim to do them all and please perfectly, but if we can't, that's when we say, to those backers that had this as their dream, understand what's happening going forwards. If it's not ready enough for you, by all means, back out, wait a little bit longer. We don't want anyone taking this unless it meets their expectations.
Awesome. So let's cover the last item, and that is obviously with a low-cost printer like this that is reliable, I can see that the educational systems might be attracted to it. What are you doing in the educational market? Are there specials? Do you have a special individual there that handles different school systems and so forth?
Sure. So schools are obviously significant for 3D printers because it allows somebody to visualize something in their mind and then go create it and touch it in reality. And that's spatial reasoning. That's STEM. It's cool. It's very technical. A lot of people, like Jeff Britton, who was in our video, the first Ninja Warrior, he said, he's such a winner. I mean, it's so cool to see this guy come on the video and say, I like this 3D printer because it lets my daughter get ahead. I mean, that one kind of set it in for me. It was surprising to hear it said that way, just bluntly. I want my kid to get ahead in life, and the 3D printer can do it. So naturally, there's a lot of schools that are interested in doing the same, and they get that. We have a dedicated department. We have 2 people that handle all requests for schools. So if somebody emails sales@printm3d.com or just goes on our website and uses the contact form, yeah, we have special deals at times. We have back-to-school promotions that we run on Facebook. There's definitely a lot of large purchases, bulk printer orders that get ordered from schools. And frankly, it's a bit of a political cluster. I mean, there's a lot of stuff that goes on before a school can make the final decision to purchase a printer.
Yeah, I'm aware of that. I tried to do the same thing with a library system, and that became a problem as well. So, I think we're about it. I apologize for that. I made some exceptions in our show. We normally only use Google Hangouts, and I tried to take a phone call.
You've still got it up there, yeah. We idolize those guys, by the way. LulzBot, it's a company to respect, and we see each other at trade shows often, and they'll get requests for tiny printers, and they'll be like, "Go check those guys out."
Yeah. Hey, so speaking of, LulzBot, one of the things that we really love about their whole product line and kind of their development is they open source everything. And you've mentioned, I think even in the early part of the show, you said that you were kind of innovating these new feedback mechanisms. Is this something that you were thinking that maybe you're going to open source moving forward?
Definitely not. So we've invested millions of dollars in what we think is very significant, very unique innovations in the industry, and that's not to marginalize the value of the open source community and what it does. It's basically just a decision to go forward and say, look, we've invested in this thing, and it's going to take some time before we even see any profits from it. So we have to protect it for a few years going forwards, and inevitably people will see the value of it and find their own way of doing it. So it should end up inspiring more than restricting.
Right. Yeah. So, and I just wonder how, I know that a lot of these, obviously the RepRap, kind of the RepRap system, right? If you build on existing firmware, you've used firmware to develop your product, there's kind of GPL type licensing or open source licenses that you use, and kind of part of the licenses, if you've built upon open source projects, that anything moving forward is not necessarily patentable. So you're protecting your IP basically by just keeping it secret, not actually patenting it.
We do both. So trade secrets have their value. Yeah, the whole open source premise is one that's fantastic, and we have used different aspects of it at times. For example, for some reason people don't know this well, the micro is completely driven by Cura internally, and one of the #1 questions we get is, can I use Cura with the micro, which we find pretty funny. Cura itself is using another open source software inside of it that I think was developed by two entrepreneurs in an academic setting, and they created, gosh, I can't remember it off the top of my head, but they created about 65% of the code base for Cura, which does a lot of the slicing calculations and math. So, you're really standing on the shoulders of giants. We exist, for example, because MakerBot made this space quite popular, and we could be a more affordable printer in comparison to them because of Cura. A lot of our very first printers were just done off of ramps just to get the idea going and prove the hardware. But at the end of the day, 100% of our firmware, 100% of our user software has been completely built in-house from scratch, and it needed to be to match the very unique electrical system that we built so affordably compared to what's out there.
Awesome. Well, thank you very much for being with us on the program and sharing with us this project. And if we want to find out more, we can go to your website, which is.
If you actually just Google M3D, that's probably easiest, but printm3d.com.
Printm3d.com, and it'll take you right to the Kickstarter page. I already been there, and what's the cheapest pledge that we can do right now to get one of these printers on order?
We're at $4.99 now, and that's
$4.99, and you'll get a printer, and you can get up and going. That's amazing. And this looks like a really nice product. Second iteration, usually this is the cheapest second iteration product I've ever seen, especially with all the improvements that you guys have put in here. So, and it looks like.
Keep in mind, the Kickstarter is a pretty hefty discount. Like a 2-year warranty is basically unheard of. That's basically like a $150 value that's added in there that's unique to the Kickstarter, and obviously retail will be more expensive because of all the features, and as people recognize that it's a very beefy high-end printer when it comes out, I think they'll be quite surprised by it.
Cool. Well, thanks again.
Yes, thank you, Mike. And again, I apologize for we're trying to bring in LulzBot after you, and they have a policy where they don't use closed systems, so they won't use Google Hangouts on air, and so they're calling in. So
Okay.
Oh well. I appreciate you coming in. That's what we've used for almost 3 years now, Chris. So.
Sure. Thanks, Mike and Chris.
All right.
Very fun.
Good luck to you, and we'll hopefully have a follow up after your campaign ends, and maybe even get a get our hands on one of these one day, and be able to share our own experience with the machine. So.
Yeah, actually, Mike, I'm going to email you. I'd like to see about getting one. Again, we like to pay for things, so if there's some way that we can get one early on and do a great review on it, I'd appreciate it. So maybe I'll contact you.
The November and December tiers are exactly for that. That's the earliest we can release them.
Great. Well, that would be a great time for our Christmas special. So again, thank you, Mike.
Thanks again, guys.
So, well, we should jump into the news.
Yeah, go ahead, and Harris will be calling me, and I don't know how that's going to work out. One of the reasons my system crashed the first time is I was trying to bring in an external mic, and the whole system crashed, and I don't know if I want to take that on again. So I may do something very crude, and that's just put him on my speakerphone via my phone and hold it up to the mic. He'll be able to hear me, and then we'll be able to hear him. And obviously, I will need to put more work into coming up with an adaptive system to take in phone calls. Obviously, we have not had to do that in the past, but we can't always depend upon that. So if the sound quality is poor, I apologize to those who are listening. So Chris, go ahead and lead us in with a news item, and then I'll wait for Harris to call us.
Awesome. Well, we have all kinds of updates, and obviously, I guess the first thing that we can talk about is Stratasys. Stratasys this week announced they're going to unveil a groundbreaking new infinite build and robotic composite 3D printing demonstrators at IMTS. I can pull this up here. So if there's one, this is from 3dprint.com. If there's one company that most people would trust to give 3D printing advice, it's likely Stratasys. The company has been around since the early days of 3D printing and has been responsible for some of the industry's biggest breakthroughs and milestones, and they are not done contributing yet. They are going to announce at the upcoming International Manufacturing Technology Show this Shaping What's Next vision, which they're unveiling 2 3D demonstrators, which are, they've partnered with Boeing and Ford and even Siemens to build a gigantic infinite build, they're calling it, 3D demonstrator. There's a short video down at the bottom of this article on 3dprint.com. Here's a part, if you look on screen, a part produced with the robotic composite 3D demonstrator. It's got an interesting geometry that required no support material because they printed it in a like a 6-axis way. And this video down here, we can watch it, and they give a little overview. It's like a big cage, almost like a CNC robotics cage, and they open up this gigantic build envelope. And apparently the parts can be built vertically. They can be built on multi-axis. So we've obviously reviewed that Japanese printer. There's some people in Japan working on multi-axis 3D printing, but Stratasys has taken it to a whole new level by partnering with Boeing and Ford for their robotics knowledge, and also partnering with Siemens and implementing these KUKA robots. And it looks like it's actually using pellets, but here it is printing, and you can kind of see here it is laying down contours of composite, multi-axis, and they're saying they can make some really big parts. If you scroll to the end here, they've got...
I can hear you. Chris, can you hear him?
Not really.
How about now? Go ahead.
Hi, this is Harris. Kenny, can you hear me?
Yeah, I can hear you.
So we're being a little backdated. I'm actually using my phone. We're having Harris call us in, and from LulzBot, and on his phone to go ahead and interview with us. And Chris, I apologize for interrupting you. We've been on kind of a tight schedule, and we started a little bit late. And I again apologize to Harris for our lateness. So I'm going to go ahead and jump right into the little video that I would normally show from each company. And this is for the LulzBot TAS 6, but I think it gives a good overview of the LulzBot, the way it looks and so forth. And, you guys aren't new to the industry, and obviously, our co-host, Chris here, he has been a huge fan of LulzBot. In fact, Chris, you have 3 of them now, is that correct?
Yep, I've got 3, and they hum along all day long.
So as you can see in the video here, which I'll jump to, we're looking at obviously the great precision of your product, and we're going through some promotions, the self-cleaning, the self-leveling, and this is all on the TAS 6, heated PFE bed, and huge volumes, which I think Chris can concur to. In fact, he's got enough LulzBots now that he dedicates certain materials to each of them. That's correct. Now, the problem we'll have, Chris, is that he will not be able to hear you because I had you fed into my ear. So I will just pipe over questions to him if you have any feedback to him. But you will be able to hear him. So obviously, we had a series of questions for you, and as you remember, Harris, in the emails that I sent you, the big thing that we're doing this month is talking about 3D in education. And we talked about design software and other things over the past month. And this month, kind of our ending point was to bring in some 3D fabricators that make reliable, decent 3D printers that are affordable, especially for school systems. And we obviously, you were one of our first 3D print manufacturers to think of. And I know we've tried to have you on before, and for whatever reason, we missed that opportunity. I did cover you at some of the trade shows that I've been at. And again, Chris is a huge proponent of your product. So why don't we kind of lead in with the first question? Do you have the questions, Harris?
Yes, sir. I've got them right in front of me.
Okay. So why don't you give us a little bit of the background of LulzBot and who am I speaking to and what is LulzBot and where are you located? I know the company name is different than the actual LulzBot, so I'm assuming that's the product name, but the company is different. Is that correct?
That's right. So first, myself, my name is Harris Kenny. I'm the Vice President of Marketing at Aleph Objects Incorporated. And Aleph Objects is a company, and then LulzBot is our desktop 3D printer brand. And so we have LulzBot 3D printers, parts, and plastics. And Aleph Objects is headquartered in Loveland, Colorado, in the United States, and we're a free software, Libre innovation, and open source hardware company.
And yes, obviously open source is extremely important to you as one of the reasons you're on a phone, that all of your software, including, I'm assuming, all your operational software, needs to be open source, which I commend you on. And obviously that's been a huge strength of the LulzBot itself. So Chris, you're the expert on the LulzBot. Do you have the questions as well?
I don't think I got those.
Okay. So obviously you have one of the 3D or top rated. In fact, Chris went through 2 or 3 weeks ago and brought up a news item that you were at the top of the list, both on Make Magazine, but you've been there for a couple of years now. And also there was another group that they were the top lead on. And, what is it that makes the LulzBot so popular? I know Chris has his answer, but I'd like to hear it from you, Harris.
Sure. Well, we're really focused. There's a few reasons why people choose our machines. We're really focused on respecting user freedom. And, that means that the whole machine is freely licensed. It means that, our users, they control the printers they buy, and that appeals to different people for different reasons. In an education environment, it means that a teacher can teach coursework on really any part of the machine. They could even teach a manufacturing class on how to build a bill of materials, how to purchase, and how to assemble machinery. from that all the way to how to use design software and to make prototypes. For most users, that also means they get to take advantage of the materials. Some folks are just using one dedicated material, but we actually support over 30 different materials, including nylons, urethanes like NinjaFlex, polycarbonate, and tough materials. So I think the big reason is user freedom, but the reason we also do well in reviews, and then also some of the more expert reviews at places like Make Magazine, is just the reliability. We've printed over 1 million production-grade parts because we still, in the rep wrap tradition, we still use 3D printing as a production process. And we use the printers to actually make more printers. And then finally, the support and documentation. We have customer support 7 days a week. We have full manuals, quick start guides, and a lot of online information for folks. So I think those are the three main reasons why people like to buy LulzBot 3D printers.
Well, obviously, as mentioned, Chris has been a huge fan, and I've actually benefited from some of the parts that he's printed for me off the LulzBot. So let's kind of go into some of the case studies you sent me. I'm looking at the Lucille Irwin Middle School, and can you tell us a little bit about that, Harris?
It's a great story, and one of my favorite things about this case study is it shows that teachers are really doing lots of different things with 3D printing. In this case, the teacher, Jacob Marshall, what he's focusing on is design thinking. So it's not just, putting a printer in the classroom and having students pull models from the internet and hit print, and then they could say, oh, we have a 3D printer in the classroom. Instead, they're developing products, in a sense, these little RC car toys and products, and also focusing on design thinking and sort of manipulating the models and making improvements and really using 3D printing as a way to learn how to think. And so it's a great story, and they're at school. Lucille Irwin is in Colorado. They're nearby us, and we've got the case study on our site on LulzBot.com, and there's also some videos that the students have made showing off their prints. It's just a really neat story.
Yeah, and actually I've got one of the videos that you have up on this case study that's showing the RC cars that they obviously had printed. So they're actually pretty cool.
Yeah, that's right. That's the one. Yeah, and it's the other thing that's neat for what Jacob talked about in the interview with our folks is that you're able to use it to kind of get interest, get attention, because a lot of the students like the idea of using new technology, and so it can be a way to sort of capture eyeballs and get people to sign up and attend even extracurricular things that maybe they wouldn't otherwise. And then once you get them in there with the 3D printing, it's an opportunity to really dig into education that otherwise might be hard to get them excited about.
Makes a lot of sense to us. All right, well, let me jump back to pricing. So you have some educational pricing. So if an educator or a school system is interested in working with you, first of all, you have an email, education@lulzbot.com. And then what I'm looking at now is again, another link that you sent me, the educational equipment that you can control, and then obviously some testimonials from certain educators. But maybe you can fill us in a little bit more. What can a educator or a school system expect, from a pricing standpoint and the type of tools, even like courseware, lesson plans? Do you have things like that set up, project guides, so that it's like an all-in-one package that they can go ahead and commit to you, and they'll be able to immediately start utilizing this in an educational system?
We have a team that focuses on really taking a consultative approach for educators, because educators will call in and they'll say, well, we've got a grant, or this is the course that I'm teaching, and I want to incorporate 3D printing. And so a lot of times we're having more conversations about how to use the printer and what materials might be a good fit for them. And so our folks really take pride in talking through that. So if you go to LulzBot.com/education, you can see what you were talking about, the materials we have there. We do have pricing discounts, of course, on the printers, the parts, and the plastics. And we also have the infrastructure in place, so when schools need to pay with a PO, if they can't put it on a credit card, they're going to need payment terms. We're used to all of that, and just sort of all of the peculiarities that teachers might have to deal with in order to get funding in place and really get the equipment they need for their classroom. So just like in a really and it's really straightforward since we're ready to work with schools in that way. But beyond all the sort of answering the questions, walking through the materials, walking through what materials might be a right fit, sharing some of these case studies. There's a lot of different ways that we partner with educators, and some of our customers are working on curriculum tools and things like that we're supporting. And so we're excited to keep doing more and really extend what we offer for educators. The biggest thing that we found, we just wrapped up a customer survey, found that the biggest thing that the teachers are doing, which isn't a surprise, but it's demonstrations. And so the best thing we can do is actually support the teacher that's running the printer, and that's where our customer support comes in. If they're going to be doing demonstrations for the students or for maybe administrators or other folks in the district that want to see the innovative stuff that's happening in their classroom, the best thing we can do is make sure they have as much uptime as possible and that printer is running smoothly for them.
Okay. Well, obviously that's extremely important, and yeah, if the 3D printer company is not supporting you, a lot of times they just collect dust in the corner. Sadly, that happens more times than not. So I'm really glad to hear that. So I'm going to have Chris relay some questions to me, but essentially, I guess our final question is, you have the LulzBot 6. Anything else you want to kind of give us a sneak peek on what you have coming in the future, maybe around the Christmas holiday for those who are saving their pennies or making hard demands on Santa this year? Do you want to fill us in, maybe? Give us a little sneak peek.
Sure. We haven't made any formal announcements yet, but what I can tell you is that we've got some really exciting projects that are in development that will expand our ecosystem, expand what you can do with the LulzBot. So we don't have any news on the 3D printers because we just announced the TAD 6, but we do have some work that we're doing in materials, several new materials that I think people are going to be really excited about that we're partnering with vendors on. And then we've also done some work in the accessories space. So we should hopefully have a new tool head that folks are going to be able to do a lot more with.
Cool. All right, Chris, why don't you pipe some questions to me, and then we'll end it with that. And Harris, again, I apologize for the delay, but I really appreciate you coming on. We're big fans of the LulzBot. Go ahead, Chris.
Yeah, so I was wondering, do you guys offer like educational discounts? I kind of heard, I know you guys have case studies and things like that, but what can a classroom, do you guys offer any discounts for the LulzBot Mini or TAD 6?
Okay. Well, Chris is asking if you offer any educational discounts, and I think I remember you making that comment. And maybe, again, what I'm hearing is a little bit better than what Chris is hearing. But you do offer educational discounts if a school system comes to you. Is that correct, Harris?
Yes, that's right. We do offer education discounts on printers, parts, and plastics. And then we can also be flexible with payment terms, net payment, things like that.
Chris, are you wanting to know what kind of percentage we're looking at?
Sure. Yeah.
Can you kind of give us a ballpark, or do you want to leave that up to the educational system who contacts you?
Oh, yeah, we prefer folks just reaching out to us so we can have that conversation with them, because it's not something that we regularly promote. It kind of depends on the situation, but generally, it's definitely significant and it can really add up. And we also offer free shipping, so it's kind of a whole bundle of things that'll show up on an order. But yeah.
Okay, Chris, does that answer the question?
Yep, that's it.
Okay. Well, Harris, I really appreciate you obviously waiting, and I know that you had your conference room on hold, and so somebody else probably couldn't benefit from this. So again, I apologize for my tardiness in getting a hold of you, but I'm glad you held out, and I know our audience will be. So thank you, Harris.
Oh yeah, no apology necessary. It's a privilege to talk to you. It's been great seeing you all at shows. So thanks for having me on. We love to talk about how free software and open source hardware can help in the classroom. So it's really a privilege. Thank you. And Chris, thank you for your business and for supporting our products. It's great to hear. So no worries. Thank you. And have a great rest of your day.
You too. And enjoy your weekend. Bye.
You too. Bye.
All right, Chris, that was great. And while he ended the call, so I don't need to. Well, it takes care of two, I think, of the leading, or at least those that have gotten a lot of information in the news lately on 3D. And, obviously every week we hear something new about the LulzBot, and obviously you have sent me components that you printed for me, and I can attest to its quality. You know, what's funny, a little backstory, we've tried to have them on before, and as you know, our audience knows, we use Google Hangouts on air, and which is a Google product, and they are very adamant to ensure that they only use open source tools. And I'll have to figure out what kind of open source, I am assuming there's something out there that allows me to do internet phone calls and so forth. So I'll have to look into that. So those who feel that they have to stick with open source will be able to handle it in the future. And I won't have to hold my phone up to my ear. So again, if there was a difficulty in hearing that, I apologize. I will work on that in later episodes. All right, Chris, what's the next news item?
Well, we covered that Stratasys machine. So the...
Okay, how about I cover really quick some items that... let's see, or at least I'll just mention them. So if you remember last week, you may or may not, since you weren't here, Chris, we had both Jesse as well as Curtis from Autodesk on. And one of the things that Jesse is working with now is the 123D series, if you remember, but TinkerCAD has been the product that they're really pushing. If you remember, they had 123 Design, which is how I cut my teeth, but it appears once they bought TinkerCAD, they've really pursued that. And the reason they're pursuing that is that it's all in the cloud, kind of like Onshape, but more for a lighter CAD work, or even an entry level, or in the case of what we were talking about, school systems. So he wanted to make sure that our audience knew that, let me bring it up, that if you're on a Mac, because as you know, a Mac's a little differently, he told me that in order to pan around, you would use the Mac trackpad and hold the Shift key and 2-finger click and drag on the trackpad. If that makes any sense. So those of you who are trying to figure out how that works. Now, if you've got, as mentioned, I talked about, will this be available on iPads and so forth? They are working on that, so you can actually use an iPad or an Android tablet as well to design in TinkerCAD. So you check back on our previous episode to find out more about TinkerCAD. Great little tool, and would work hand in hand with the LulzBot or even the M3D in designing little things. So pretty cool in that perspective. So that's an update. The other thing I want to mention is Android 7 has been released for only a few phones, in particular the Nexus line from Google. So expect maybe anywhere from a couple of months to next year, depending on your phone carrier, for some of the more advanced phones. Obviously, the less advanced or the newer phones, the older phones, probably won't get it till much later or at all. Some people have thought it would follow the course of previous versions of Android updates, but I think it'll be a little bit quicker, and the reason for that is that they've had a long beta period or public beta, as well as for manufacturers. So I do think that we may see it sooner than later, unless you're on Verizon, and then it might be when hell freezes over. But, oh well, they do have the best service, right? I don't know. Are you on Verizon, Chris?
No.
No. Okay. See, well, he's a smart person. I'm not. I have been on Verizon for some time. Okay, so let's get into some of the other items. I've got, well, some VR tools that that Jesse also brought up to me, and we didn't get to it last week. So if you are using Autodesk applications, they have a product called VR Panorama. So that allows you to view your scenes in their tool. So you can actually click on it, and it'll go to an Android device. Let's see if it actually is just Android, or I don't even know. This is the first time I've seen it. Okay. I'm not getting anything except a screen.
Yeah, I think that this one is like some of the other VR stuff I've seen, is it's WebGL. So I think it's semi-hardware agnostic. It's any phone that'll fit into the Google Cardboard, and then you just kind of line it up. So it's actually in the web, which I've seen more people start to kind of adopt.
Yeah, and I have been working with it as well. Some caveats with that: you need to make sure, especially if you're using Google Chrome, that you have WebGL extensions, and that's only available in I guess the beta version, and then you have to turn it on, if I remember correctly. It's not something that's automatic. If you're using it in the browser on your phone, you need to go with Google Chrome Developer, and again, you have to go into the extensions and make sure WebGL is turned on. So it's not an auto process at this point. It may be soon. So I don't know about that particular product. He does, there's a couple other links I'll make sure in the show notes. There's a product called Autodesk Stingray, and then there is a tool for Maya that immediately will create panoramas. So if you're a Autodesk Maya user, there's a new plugin that'll be available for that. And there's supposed to be some new items also coming. So we didn't get to that, but yes. So they do look like they have some type of strategy for VR, which I think is very cool before making that next step in the tangible products. And I can't wait to the day, which I've been working on feverishly, to be able to walk around something that I've designed to inspect, kind of like Microsoft HoloLens on a budget. But we're not quite there yet. All right, Chris, you've got something. We talked about the amazing 3D printed full-scale Stargate. What's that about?
That's crazy. This came to 3Ders.org. This is crazy. Took over 1,000 hours to build this 3D printed full-scale Stargate. And you can scroll through this article on 3Ders.org on their front page. And here they are building it, piecing it together. Look at this thing. Huge. Huge. Stargate. And here they are building it. So part of it CNC'd, a lot of it 3D printed. They had a huge array of these Flash Forge builders.
Oh, how funny.
3D farming this thing. And they have it all packed. I don't know where they got the budget for this, but man, and they're doing it in like a fountain, so
this is at a school?
Apparently so.
Why don't you expand your window a little bit so that we can see it in its full glory, because I'm assuming the end shot will be it being made. So obviously I am old enough to remember when the movie came out, which I thought was pretty cool at the time. Did you actually see the movie?
Oh, of course. Yeah, Stargate.
And then I guess there have been a few series that have continued, which I didn't follow. So
yeah, Stargate. They inject these little bits of truth and via science fiction. A lot of the stuff in Stargate is actually like real stuff, possibly. Who knows? It's interesting stuff. Once you get into the pyramids, what they were doing in the pyramids. For the longest time, we thought they were tombs, and some people say they weren't tombs. They were tombs later on, but before they were tombs, they were something else. You know what I mean?
Mm-hmm.
So,
who knows?
Yeah, who knows? So
I'm going to get right into, I don't have anything for 3D in medicine, so I'll get right into my scanner. And this is great for anybody who's on a budget. Now, as you know, that I have covered and do some work for Occipital and their structured sensor, but they don't really have anything for Android at this particular time. So TechCrunch released this little article, and I've actually had some conversations with Scandi in the past. They developed an app for the structure sensor in the iPhone, but it looks like they're moved on and are using this little device from I think it's a European company, if I remember correctly. And they have a link down here later on, but in order to keep this quick, I'll play the little video here. But essentially, with this little scanner, and it's a time of flight scanner, very similar to, actually it is the same technology used in the Project Tango. Using time of flight versus structured light, they're able to capture, just kind of like the new the Connect 2 3D fabrication. And there you can see the tininess of it. So you can put it on the back of your phone like they have, and be able to use your Android phone now to capture down to 300 millimeter resolution, which is pretty good. So there they go. So the refresh is like 3 frames per second, which is pretty good. And then there's obviously a mesh. Yeah, I don't know if that was created, but there's another mesh. So there are some examples there. So it's another option. The company who makes a little scanner, you can get on their developer kit for $100. I don't know what Scandi is going to be offering it for. I've signed up for their development, and I would probably get them on. If you remember, we had, who is the company out of Canada, Chris, that Matter Informed, you remember them? That we both ordered their little tiny add-on to the phone. That's we're going to have an update next week. Hopefully we'll have somebody on. They're close to shipping on that thing, Chris, which is also a very reasonable little tiny scanner. So obviously, as I mentioned, I thought 2016 would be the year of the low-cost scanner, and it might still be. So if you're interested, here they say it's going to be less than $500. And maybe it'll be less than that. As mentioned, the actual sensor here can be bought as a developer product for about $100, and you can sign up. There's a link to, and actually it's right here. The company is called PMD Tech. And then you can actually order it. Let's see. Products. It's called the Camboard Pico. There we go. And they have a developer kit right there for about $100. Now again, a developer kit is not a full-fledged product. So if you are a developer, it might be something to sign up. I signed up as well, so I'm looking forward to seeing that. But combined with some software, you can have a very portable, decent little low-cost scanner, just like the structure sensor for iOS. So good to see my Android phone is getting a little bit of love there. Okay, so that's about scanning. Let's kind of get into some VR, and there's kind of like a great article that was done on Road to VR. It was written by Yuval, which I've talked to on several occasions. Yuval is the CEO of Sensix, and they're the ones behind the OSVR. And as you know, I've covered that before. I've had some pluses and minuses with it. The new HDK2 is pretty good, but he really knows his stuff. If you want to go out and read his blog, he's got all kinds of great information about VR. Another thing is he's open source, so a lot of his information is available. So if you're interested in designing, but he has some great insight into it. And this particular article is written about what they call binocular vision, and that is what each eye sees. And this is extremely important. He goes through and provides some great information on how that occurs and what depth perception is and how it actually can be utilized in a VR headset. And he goes through and identifies through both some great images as well as text of what it looks like, and if you use partial or no overlap, as indicated there. And overlap is very important because that's what determines the depth. And but you also have what they call binocular rivalry, which essentially creates bleed over from one eye to the other, which kind of gives you somewhat of a ghost image type functionality or image. And so he talks about that as well and the challenges. So it's a great little article. Plus, he does have a blog with other things, and later on I have a link to something I'll be using to discuss something that I have found out in the new Samsung Gear VR, but I'll leave that to a little bit later. So that's a cool little article. And it looks like you've got an item as well, so why don't you go ahead and cover your item, which looks like a new camera, huh, Chris?
Yeah, this is really cool. This is I got this email from 3DR Solo. You know, I've got my 3DR Solo, and I haven't had a super great experience with my Solo. Unfortunately, it still sits broken.
What is that? If you don't mind.
It's a drone, a smart drone, and it has all these cool features. And when I first got it, it was great. Well, semi-great. It works all right when you get it working. But KODAK, they have this awesome ecosystem of products. That's one of the great parts about 3DR is that they've kind of opened it up, and they have this open development platform. 3DR was one of the first smart drone companies to kind of open up their hardware and their firmware library, and actually they have the pickaxe controller. So KODAK has unveiled with 3DR a system that straps onto the back of this. It's called the SP360 4K. It's an aerial pack that includes 2 SP360 4K VR cameras and a Solo mount. And what that does is that turns your smart drone into a VR 360 capture device. So you can go fly your Solo around and capture 4K, 3D, 360-degree data for $9.99. So you can buy one of these drones right now. You can buy the Solo drone. I think it's $6.99 or $5.99, and then you buy this $1,000 camera system, which is a camera on the top and the bottom of the drone, mounts on, and lets you capture stereoscopic 360 spherical video, which is pretty cool.
So it is actually stereoscopic?
I believe so. I believe that's what it says. I think that's why it needs the 2 cameras. Yeah, because it's for VR. So it secures one VR camera to the top, ultra quick assembly, tell your story, and I'm gonna have to find more.
Well, the important thing is, I've obviously not only have I done it physically with dual cameras, but also I've synthesized it. Stereo 360, I think, is the future. It is coming from other companies as well. In fact, we'll be bringing up a future camera that I'll be reviewing. But I think if it is stereo, that's a great price, because normally you can't find it unless you buy those huge camera arrays. And from my experience, I think with that particular KODAK camera, it'll give you stereo in front and stereo in back, but you lose it on the sides. But you don't really need it all the way around, I don't think. But I don't know. I'll have to look into it. But it adds that extra level of depth that makes you feel like you're there. Or at least that's me. So that's kind of cool. For so less than $2,000, you can have a decent VR experience in the air. Wow. All right, Chris, I'm assuming you probably want to go ahead with your Print Whisperer, and then I will cover my items, which is going to be in detail why I think there's been some woeful disadvantages to the new Gear VR, and I'll tell you a little bit later. So go ahead, Chris.
Awesome. Well, again, we're going to keep going. I'm going to keep continuing on with this 3D in education, 3D printing in your classroom type thing. We talked about it the last few weeks. Last week I was out. But this week, again, I want to reiterate safety, because this is like a top priority in a classroom or even a shop. This is like priority number one is obviously safety, because if something causes injury to just even one person, it's likely to be abandoned by the teachers and faculty, or even the executives or whatever it is. They'll abandon the technology or abandon something if kids are getting hurt, if employees are getting hurt. So, 3D printers, they have super powerful motors that can pinch you, hot ends that can easily burn you. Even the build plates can burn you, and the tools that you use to remove or cut parts can easily cut you, poke you, stab you. They can really get you hurt. And like last week, I'm a picture perfect example of I was wearing gloves clam knife broke apart free, came across my hand, cut through the glove, cut 2 of my fingers down to the bone, real nasty cut. Yeah, so definitely important. And if I hadn't had gloves, you know, who knows what would have happened. So definitely wear proper safety attire, have a first aid kit nearby. Get yourself sturdy gloves. The gloves I was wearing were not appropriate. They were Costco kind of flood control type gloves, like the type of gloves that you wear. They had like rubber backing, you know, but what you want is like real sturdy gloves. I really like the mechanics gloves. They sell them on Amazon. They're a little pricey. They're like $15 for a pair, but they're worth having a set. Whoever's working on the printer, it'll keep you from getting burned. It'll keep you from cutting yourself if you slip with a knife. Proper tools. Get yourself a pair of proper tools to get the parts off the build tray. The one Mike, I still use that thing every day. The one that you got me, the cry cut spatula. Sometimes the stubborn parts won't come off with that because it's too weak or it's a little flimsy. So you got to get the clam knife. LulzBot has the clam knife. So you just got to make sure no pointy objects. Don't put anything. Don't use super sharp knives or anything to get the parts off. It's just not worth it, you know. So take a lesson from LulzBot. Also, I really like they build in these cooldown procedures into the G code, which some printers they don't do. So you can go and find the G code. You can go find online. You can look up some G code. There's cooldown procedures for different types of filament that make removing off the build plate really easily. So wait to unload your part until that little process is done, and then you can remove it. It's a lot easier. If you try to remove it when it's still hot, it's kind of a pain. So and then obviously the number one thing to safety is just practice common sense. Remove the parts away from you. Don't use sharp stuff and get yourself out of the way. Wait until the thing cools down before you touch it or anything. So common sense definitely there, but don't hurt yourself because you're going to actually ruin the experience, not just for yourself if you hurt yourself, but you're going to ruin the experience for other people because, you know, if you hurt yourself, the teacher is going to say, that's it, no more. People are getting hurt. So safety is a priority and try to instill self-police the other students. If somebody's doing something stupid, tell them, hey, don't yell at them, but explain to them, hey, if you hurt yourself doing this, it's gonna affect the whole class. So be smart and be safe.
Yep, totally agree. And actually, I was going to show my hands. Let me. Let's compare hands. You know, like
well, the stupid
jaws,
part was
scars. Look,
so the stupid part is on Monday of last week, I cut one of my fingers doing the exact same thing. But then on Thursday of last week, I cut myself. That's when I cut the 2 fingers in one thing through the glove. So twice in the same week, doing the same exact thing on the same printer. So NGen is one of my favorite filaments, but man, it sticks to the build platform so well that it's hard to get off. So you got to like really pry it off with that, with the clam knife. And I was just being dumb. Just should have been cutting away from me, but you know, the parts they get stubborn and you just want to put your back into it and try to get them off. Yeah.
Yeah. The other day, as you know, working on my NeoDVR Uplay, I was drilling a hole through because as you're probably aware of, it has hinges. So I have actual metal rods that go through it, but I have to clean out those pathways. So I was using probably more force, but it's a very, very small, I'd say maybe like a 3 millimeter bit. I mean, it was like extremely small. That may even be too thick, but I slipped or it broke and went straight through my finger. So
yikes.
Yeah, but I guess having one that thin wouldn't be any different than a needle. But it was funny because I looked at it and I said, oh, that doesn't look too bad. And then I noticed I was looking at the entry wound, not where it went into. So Luckily, it didn't break off like the guy in Mr. Robot, but that's another story. You watch Mr. Robot, Chris?
Yeah, not season 2 yet, though.
Okay. Well,
Yeah,
when you get
so
around to
give
watching
anything- yeah.
season 2.
Well, I'm
I
waiting
won't
for it
give
to
you-
come to Amazon, you know?
No, that's a good thing. You should get cable or something.
Yeah, right.
Desperate for that. Yeah, I'm trying to think. Oh, well. It's all right. So I don't want to waste any more time. Let's get right into my subject, and I'll go ahead and don it. So in your absence, over the weekend, I did a review of this little unit here and the Note 7. And talked a little bit about some concerns. So then I did some investigation and some research and a little math and some test images, which I'll bring up in a moment. And to find out that this thing really was compromised when you use it with a Note 4. In fact, this thing was designed for the S7, which is a 5.1-inch screen. And if you know, the Note 4 is a 5.7 and the Note 7 Edge is a 5.5. If you want to buy this, your best experience, and I'll explain why in a little bit, is the smallest phone. Because if you look at the eye holes here, in fact, I can give a small, I mean, here's the screen. Can you see it, Chris?
Mm-hmm.
And see the holes. Notice that the holes undercut the edges of the phone itself. So you're literally losing like 10-15% of your screens due to this. And I have some measurements that I want to show. So in my opinion, even though it's great, there's a couple things. The magnification is higher, so the PPI on a larger screen, especially at the same resolution, is going to be wider. So the number of dots and the spacing is going to be more noticeable if you know the screen door effect, like in the DK1. So a larger screen with the same resolution is going to have a higher screen door effect than a smaller screen. And so that's one of the disadvantages of using the Note 7. But the other is you lose part of your screen. So you have this like binocular experience, I mean literally like little tubes in front of your eye, and then you lose the edges. So you're, even though it provides you an immersive and a little bit more FOV, it's not really seen on the larger phone. It's seen on the smaller phone. So one of the things that I did, which I thought was pretty interesting, the Note 7 is a USB-C phone. So it comes with a little adapter here that can be removed so that you can use it with the previous S7, and it may even work with the S6, which is a micro USB. So it comes with two of these, and it just slides on. Well, one of the things that I found out, and I think I have it in my pocket here somewhere, yep, is that if you remove the actual micro USB, because it just has some small Phillips screws on it, and remove it, you can then use this with any phone. So I was able to use it with my test little LG G5, which is a 5.3 phone with a 25 by 60 1440 screen. Very high resolution, so it now fits in here. Now, you don't get any of the electronics, which makes this an advantage for those who own a Samsung phone, but it still has some decent optics. It's lightweight, has some good, but it's $100, so it's pricey. The other disadvantage is for Google Cardboard, it doesn't have a capacitance switch. So you can't really do much with it unless you use gaze control, and a lot of people are getting away from that. So for less than $1, I've added one, and I've used this on some of my other products. There is some electrically conductive fabric that you can buy with some adhesive backing. This is a 1/4 inch thick, and then I just got some 3M, I have both of them here, some 3A and 3M VHB, and I just created 2 layers of this to create a little bit of a cushion and backing so that it provides enough pressure on the phone. And essentially, because it's conductive, when you touch it, the capacitance discharge, what it does is it modifies the capacitance field on the phone itself, is then carried over through this little plate. So it's not even a switch per se, but none of the other cardboard devices are either. They just have like a little nub that touches the screen, providing the same thing if you have one of those little nubs that you use. Remember the old days on iPad? You got the same technology, but for less than $1. In fact, if you can get enough people together on it, because I think it's like $4 or $5 to buy a roll of this, as well as the BHB. If you can get enough people together, you only need less than 1 inch of materials. I think for pennies you could add one of these, and then you could have a capacitance switch to your Google VR, which is what I did. So now I'm able to use it with any phone. But let's get on to the next part. So this is a pattern that I created. And I've used this on several phones to do a lot of tests. And what this does is it's actually set up for stereoscopic, so you actually see this in both eyes, and then it has a gradiated line in between that goes out to about a 750 on each side. And that, if you basically divide your, and I have it, and it'll be in the show notes, if you divide 750 by the length of your screen, that'll give you the what do you call it? The gradical spacing for your phone itself. And then you can use that to determine how much of your screen is cut off, or literally what you're seeing in the screen, and then determine percentage-wise of how much is being cut off of your screen in your own viewer, and also determine your FOV. So I want to jump to this little link that I have, again from, let's see. Hang on just a second, and I'll hit it. Here we go. This is from the VR guy, which is the same person who's the CEO of Sensex, also the guys behind OSVR. He created this little chart that tells you, depending on the aspect ratio of your screen, basically the diagonal field of view. And what it does is it combines the hypotenuse of both the horizontal and vertical to come up with, and he has the equation down here, in order to come up with the actual FOV. And I think everybody should standardize onto this. So the FOV of my little Uplay is about 113 horizontally, but since it's a 16:9 screen, most of them, if you look up 113, the diagonal for that is about 120. So my diagonal FOV on the Uplay is about 120. The diagonal on the Samsung that I have in my hand here is about 109. Let's go 110. So again, that's all dependent upon the ratio of your screen, and since most phones are 16:9, so you're literally looking at a horizontal of 113. Now, keep in mind, this is for a small phone. A larger phone, because if you know, it's think of it like a cone, it sweeps out. So if you're cutting off the edges of it, you literally are removing part of that, and that's the reason why it's 109 and can't really be pushed to 120. So in my opinion, I think they should have designed this, since it already was set up for a USB-C, specifically for the Note 7, widen the gaps here so that this channel or the spacing here could accommodate 120 and have a better experience, excuse me, with the Note 7. And also because they can actually modify the focal length in order to move it back a little bit, it would also remove some of the screen door effect, because you would have less magnification as well. And so here's some results that I took some images internally. This is what I got from the Note 7. Notice it only goes out to about 500. Now, again, this is just a camera. You'll actually use your own eyes to determine what you can see out to the edge, but that's about the extent. Now, this is when I put in my Note, or excuse me, my S4, which is a 5-inch screen. This is what I was able to get with it, almost out to 700. So you can see that there's a huge difference in the amount of screen that you're able to see between a smaller screen on the Galaxy Gear VR, depending on your phone size. And also, I mean, it's difficult to see here, but did I not switch it yet? Yeah, I did. But the density, pixel density, is much better, especially if your screen size is let's say a 5.1, which is what the S7 has, and you're still using the same resolution, which is 2560 by 1440. That means you're packing more pixels into the same space, less screen door effect, and a more, I wouldn't say vibrant, they're both pretty vibrant, but it seems smoother and more realistic. And some people are still opposed to that screen door effect, and we're really not going to see that go away until we hit 4K. And there are a lot of challenges to move in that direction. So that's about it. If you don't have anything else, I think we can about head out. We're still not into anything new in the news, Chris. But on that note, I think I've covered about everything. What do you think?
Yeah. No, I think thank you so much to 3ders.org, KODAK and 3DR, LulzBot, 3DM, right? M3D, yep. Excuse me, M3D. Coming on, 3dprint.com and autodesk.com as well. So thanks to all these guys. And thank you, Mike, for filling us in on the the limitations of this. On your Gear VR. Very interesting to see all that stuff. So, and we will continue to carry on and see you next week on another episode of All Things 3D.
Bye.
Bye.